For this problem, we're going to solve a compound inequality. Here again, we're going to solve our inequality and express our answer in set builder notation or interval notation, and then we're going to graph our solution set. This problem's a little different because we have two inequalities in there, a compound inequality. We don't have to do a lot that's really different for this. We just have to remember that what we do to one part, we do to all the parts so that we're consistent. We still want to isolate this x, and we want to keep that in the middle. So the first thing we're going to do is subtract 3 from both sides, or I'm sorry, all three parts. So we subtract 3 from this part. Negative 7 minus 3 is negative 10. I'll have negative 5x left here in the middle. And then it's less than or equal to 8 minus 3, which is 5. So we've isolated the variable term in the middle. We want to get that x by itself. So now we're going to divide all three parts by negative 5. What's important about this is that when you multiply or divide both sides or all parts of an inequality by a negative, we need to switch the direction of our inequality. So here we have negative 2 over negative 5, which would give us a positive 2. We need to switch the direction of that inequality, so it's greater than. Here we'll have just x, and here we'll have greater than or equal to negative 1. Now we typically will read from left to right, so we're going to rewrite this and put them in increasing order. Negative 1 is less than or equal to x is less than 2. Our set builder notation then will say the solution set is all values for x such that negative 1 is less than or equal to x is less than 2. For the interval notation, this makes it really easy. We see that this inequality is non-strict, so we're going to use a square bracket. But this inequality is strict, so we're going to have a parenthesis. So at negative 1, we use a square bracket because we can include that. And at 2, we're going to use a parenthesis to show that we don't include 2. So the interval negative 1 to 2, but not including 2, is our solution set. The last thing we need to do is graph that solution set. So we'll draw our number line. I like to mark off 0, mark off negative 1, mark off a 2. And then now we need to graph all values for x that are between negative 1 and 2, but we want to include negative 1. So we put a square bracket at negative 1 and a parenthesis at 2, and then we shade in between. And there's our graph.